Go to the people.
Can we do it after the class? Okay, so let's start again. Again, if you have not yet created the group, please create it and send this information by today. If not, then I will assume that you just want to do it alone. Okay. So today is the deadline. Okay, so here is another example. Think we have not covered. So let's go to example 12. Let's say there is a mismatch dot text. So let's say we have this 21st century. So what if we try to use dot next int for 21st? It's gonna give an error of input mismatch error. Okay. So if we try to do this, then it's gonna consider 21st as integer, but 21st is not an integer, right? So in order to like stop this error, what we can do is we can use this dot has next int or dot has next or dot has next double. Okay, so when we do this, what's going to happen is we will not get any error. So we will see if the input or if the text we are getting from the file, if it's integer, then store it as an integer. If it's not an integer, then maybe store it as a string or maybe as a double, whatever you want to see. So now if we run this, we don't see any error, but again, we don't see any output either because we are not storing anything in the value, because if it goes to the file, it sees we have 21st and century. They both are not integer. Okay. So let's try to do something like this. Yeah, okay. So now we can, so it's not, let's see. If, yeah, again, if it's integer, again, it's going to return false. So we are not going to run these lines. Okay. So the whole idea is dot has next int function is going to return true if it's an integer, otherwise it's going to return false. And finally, so again, a very basic example of why we go through these like text inside a file. So you must have heard about antivirus, right? You must have installed it in your computer, like, once in the lifetime. Again, antivirus, they are not secure, but still what they do is, so whenever you send something on the Gmail, like .pdf or any code, so what happens is Gmail or maybe any antivirus, it scans it, and it scans it for malicious like commands. So let's say there is some command inside your file. On example 13, let's say there is something like PowerShell.exe. So what happens is, let's say someone sends you a code or someone sends you a file, let's say a PDF, your friend sends you a file. What happens is when you click on the file, there are certain commands inside the file that automatically run when you run the file, and it give access to your PowerShell, like Windows PowerShell, to your friend. Now there is a tunnel between your computer and your friend's computer. So that's called social engineering. Or maybe the people it's really easy to bluff them. Maybe if I create a file and send it to you, and if you open it, I can hack your data, right? So the whole idea here is why we read the files. One way is, like one example is the antivirus, they, or maybe the scanner, they goes through your file and look for all the possible malicious commands. Like they check if you are writing some commands that are actually giving access to someone's outside your network. So if it's like this, then it's like it blocks. So let's try, like always try to send some Python code on Gmail. It's gonna block the code because there can be anything inside the code. like which can create a tunnel between you and your friend's computer, okay, or like anyone. So the whole idea is in the antivirus, they actually go through your file, they scan through your file and look for some possible malicious commands. Let's say PowerShell.exe is like one thing, because whenever you run something in PowerShell, you have administrative privilege and you can do anything you want. So that's very basic example. Well, so that was about text files. So now let's talk about binary format. Um, Most of the times, um, if you see some softwares, there are some .dll files. If you try to install a game, .dll is missing or something like this. So these are all binary files. Okay, .bin, .dat. These files are binary files, and why we use them? It is really easy to manage the data in the binary format. So in the binary file, in the text file, your data is stored as text object. Like you can see Mary had a little lamb. But in the binary file, your data will first be converted into hexadecimal, like E830FD, like this, and it will be stored on the file. And it has two reasons like why we use binary file, because it is memory efficient, and another thing is we are going to see that in the example, like why we use binary files. With the example it will be easier. So the text format is human readable format as a sequence of characters, and the binary format is data items are represented in bytes. Okay, and the advantage of binary file is they are more efficient to process than text files. Let's see binary files. So in binary files, data items are represented in bytes. Okay, so instead of like storing the whole strings inside a file, you define some bytes. Okay, for each byte there are 8 bits, so you convert your data to bytes which computer can process efficiently, and then you store it inside a file. So let's say we have this 1 2 3 4 5. The hexadecimal representation is 00003039. And again, we will see the example of how to convert to hexadecimal, but again, this is not a point, because binary to decimal to hexadecimal, I assume you have this knowledge from your high school because they teach that. Okay, so even if you don't know this, you can learn about it. Hexadecimal is, I think, base 16, decimal is base 10, binary is base 2. Again, that's high school mathematics. And I'm not going to ask you to convert something to binary and store it, okay, inside a file. So you don't have to remember, or if you don't understand how to convert decimal to binary, that's okay. Okay. So the whole idea is, and we are going to see how binary files are different from text files. We will see that example. So to to read and write binary files, you can use file input stream and file output stream. So file input stream creates an input stream object, and you can pass the name as input.bin and output.bin. And the binary input, so you use the read method of input stream class to read a single byte, and you read the file byte by byte. Okay, so you read first byte, second byte, third byte, and you convert it back to human readable format, which is string. And we check if it returns -1, like you again use this next variable and you use the read function. If the read returns -1, it means the file has been ended, like there is nothing after the text has been taken. So, and again, to write, you use output stream. You take int value somewhere between 0 and 255 and you write it. And once you have processed it, you need to close the file. Again, you don't have to worry about these things. Let's go to example and see like how we treat binary files. So binary files, I think it's here. So let's say you have a boolean, you write it as true, byte 12, character A, short 256, integer long, float, double, like all the data types you have, let's say, and you have a string. So again, you create a file variable example1.bin. Now here you see we are not using dot text. Okay. We are using dot bin, and we are creating file output stream and data output stream. The file output stream, will help us. The file output stream and data output stream, it's going to help us write the data in the binary format. Okay. So, so once you have created this data output stream object DOS, you use, in order to write a boolean as a byte, you use write boolean. If you want to write byte as a byte, write char, write short, write int, write long, float, and double. So all these functions are there. And when you try to write an integer as a byte, it takes 4 bytes to represent an integer. You have to remember that. And if you want to store double, it takes, I think, 8 bytes. Okay, we are going to see in the example. And whenever you want to write a string, you need to write it as UTF, okay, which is a universal format. And finally, you close the file. So let's try to run it first. Again, I think it has created this example one.bin. Let's try to open this example one.bin. So you see, what you are seeing here, these are weird characters because the data is represented as bytes and you don't see what's happening. Okay. Again, we will read this file online and we will see like what has been written. But let's first take an example. So let's try to save 1000 in binary file. Okay. So 1000 is an integer, right? So when you want to store an integer in the binary format, it takes 4 bytes. So you have to somehow represent 1000 in 4 bytes. And how you do that? Again, if you don't understand this, that's okay, but I will try to explain. So 1000 in binary can be represented as this. So if you try to convert 1000 to binary, you are going to get something like this: 11101000. And each byte has 8 bits. It means that 4 bytes have 32 bits. So you convert your 1000 in binary as this. So the first byte is all 0, second byte is all 0, third byte you are going to take these two and append it here because these 8. So each byte can only represent like 8 bits. So once the 8 bits are here, you put the 2 bits here. Okay, again, that's high school mathematics. And in order to convert it to hexadecimal, you take an AND operation of 0xFF, which is all 1. Okay, which is all 1 in the binary format. So you take AND operation, it becomes E8 in hexadecimal, it becomes 3 in hexadecimal, 0 and 0. So let's go to write binary file. And we have implemented this thing here as bytes. So what you wanted to do was you had an integer value which was 1000. You created an file output stream and you took the integer value which is 1000 and you performed AND operation. And then this is a shift operation. So we took first 8 bits, and then we are taking next 8 bits, and then we are taking next 8 bits, and then we are taking next 8 bits. So we are doing this like this AND operation for each 8 bits, and this 0xFFF is 11111111. Okay. But again, you don't have to remember this. So once you have written these bytes, you close the file. Okay. So let's run it. 1000 has been written to the binary file. Okay. So if I go here, okay. So if you go to this website, read binary files online. Okay. So if I go here and if I try to read this binary file, again it shows weird characters, right? But I just want to show you that how the data is stored in the binary file. So let's try uploading it here. Let me copy this. You select this file and here is this binary file. So you can see that the first byte is E8, the second byte is 03, the third byte is 00, and the fourth byte is 00. So your data 1000 is represented by 4 bytes. Why? Because that's an integer, and when they were creating this library, they just said that an integer can be represented as 4 bytes. So that's how you represent 1000 in binary. Okay. And in order to convert it back, read binary file. So let's say this is read binary file. So again, what you are doing is you are taking the first byte, okay, and you are adding it as an integer. Then you are again shifting to the next byte, which is 8 bits. And finally, you get the answer, which is 1000. Okay. So that's how you store your data, which is represented as integer, to a stream of bytes. Okay. For every integer, we store it as a 4 bytes, and for every double, we store it as 8 bytes. So that's how you do it. You had E8 03 0000. In the first run, you do something like this. Second run, you do something like this, and finally, you have this hexadecimal of 0x00E3E8. If you convert it back to decimal, that is 1000. So the whole idea of binary files is you take your data as an integer or double or string, you convert it to stream of bytes and store it in the binary file. Okay. And it's efficient. Again, how I'm going to explain in the next example. But I mean, I'm not asking if you understood this mathematics, but the whole idea is, do you understand the whole idea of binary files? Instead of storing the data as an integer or string, which you can read in the text file, what you do is you just store your data as a stream of bytes. That's it. And what bytes are? It's a combination, like it's hexadecimal. You like represent your decimal notation like 1000 to hexadecimal, and you strict it to 4 bytes because an integer is represented as 4 bytes. So any question from this, like, concept of how the data is stored in binary format? If you don't understand this, that is okay. I mean, I don't ask you to do this, but that is difficult, right? I mean, imagine I give you like a very big file and you are just doing this computation and again and again. So for this, you don't have to think about how you convert your integer to 4 bytes or double to 8 bytes. You have this data output stream. Okay, this library or this class which we have seen in example 1. So if you go to example 1, you see, if we want to store, let's say, boolean as bytes, we just use write boolean function. If we want to store character as bytes, we use write char, write short, write int. So, and we don't care about the implementation, the underlying implementation, how an integer is converted into 4 bytes. Okay. So you just use this function write int and it's going to write it in 4 bytes. And I think it's going to write it in 8 bytes. Yeah. Okay. So it's going to write it as 8 bytes. Okay. So you can see here, this write double, write it as 8 bytes. Okay. And in the example 2, we can use the same read operations to read. Okay. So let's run this. Yeah. So when we had this, I think it's something, but let it be. Um, so when we wrote something in the file, we knew that what we have written, okay? And when we want to read it again, it's not like you just take a random file from the internet and start reading. I mean, you need to know that in the first place, you wrote a Boolean. In the second place, you wrote an integer. In the third place, you wrote a string. In the fourth place, you wrote a double. Because when we are going to read the data, we are going to assign, let's say, 4 bytes to int, 8 bytes to double. But if we don't know that integer is at this place, then we might, mess up with the bytes. So the whole idea is we are going to read the data in the same order as we have written. So we wrote Boolean first, so we are going to read Boolean first. Then we are going to read byte, we are going to read char, short, int, long, float, double. And that's how we get this data back. Okay. So that's the whole idea. And you don't have to worry about how things are implemented. Just imagine there is a function, this I think this is example one. There is this function write int. So this function basically converts your integer data to a 4-byte hexadecimal and store it somewhere in the file. Okay. And you don't have to worry about the implementation. And I won't ask you to do that. Okay. You just need to know if you want to write an integer, you need to use this function. Okay. If you want to write a float, you need to use this function. And if you want to write a double, you need to use this function. And if you want to read something like this, you need to use read functions. Okay. So I don't ask you or I don't expect that you remember everything, but it will be there with you. So you see, and you need to understand like where you want to use which function. Okay. So your exam is going to be something like this. Maybe I will give you a write file and I will ask you to write a code for read. And if you don't write in the same order, that's wrong. Okay. Got my point? Any question? Okay, perfect. So that's how you write your data in a binary format. So first we have seen how you can write your data in the text format, and now you have seen how you can write your data in the binary format. It's not difficult. The libraries are there. You just convert your data to binary, okay, to hexadecimal and store it inside a file. Now we have random access. So previously, if you remember, in order to read everything, we first used to read a file object, put it inside a scanner, and use a for loop or while loop to go through each and every line of the scanner, right? But what if the file is very big? Like it will take a lot of time to start from start till the end. What we want to do is we can randomly access data in the file. I should not start from 0 and go till like 1 million data. Okay. What I want to do is I want to store my data in the bytes in such a way that I jump from like first byte to third byte to fifth byte, and I know how I have stored the data. So random access is in your file. You mention that I want to go to this number of byte, let's say 100 position. So the data at 100, it will be returned to you. And that's how it works. Let's say you have a bank account and you have two instance variables, account ID and the balance. So what you do is you store your data like this. 1001 and 900. Let's say in the text file, you store your data like this. So let's say you want to deposit, let's say $100. Okay. So this 900, if you add 1000, it's going to take the white space here. And imagine if you want to add, let's say 9 more thousand, then it's going to overlap with this data here. Okay. So the whole idea is if you work with text data, the data size increases or decreases, as you go, like as you move forward, it's a possibility that your data overlaps with the other data that is already stored. But in the binary format, imagine like you give 4 byte to every integer. So now you don't have to worry about your data being overlapped to other data. Okay. So now these 4 bytes are specific for an integer. Now this 4 bytes of integer can store a very long number, and you don't have to worry about, okay, if my data is going to overlap with someone else's data. So that's how these binary files are more efficient than text files, because when you give a static number to certain variables like string or integers or double, then you can represent your data, I mean, in a nice form, in such a way. Now we have like an integer 1, it is going to be represented as 4 bytes. And even if we have an integer of 100,000, it is again going to be represented in the form of 4 bytes. So you don't have to worry about your data being overlapped with other people. And that's when I said that it's efficient. So that's how it is efficient. Okay. So um, so the numbers use a fixed amount of storage space, making it possible to change the values without affecting surrounding data. And the only disadvantage is you cannot read the file like with your eyes. I mean, since the data is stored in bytes, so you have to somehow convert it first. And that's how you access, uh, that's how you operate with random access. So let's say there is a file and you want to open it, and you use R for read only and RW for read and write. So that's what I was talking about when you asked we can append. So it's something like this, like you have to give something like this in the constructor. Um, if you just want to read and if you just give read, then you will not be able to write the file. But if you give R and W, it means that you can read as well as you can write the file. And f.seek, I'm going to explain what's that. Length and get file pointer. Okay, so what's the example? Yeah. So example 3, let's go to example 3 and I'm going to explain everything. Let's say we have this bank account class. It is very simple. Like you have a constructor which assigns the values. You have a write data function which takes the file and write an integer. Again, an integer is represented as 4 bytes. And then you have a function read data that takes the name of the file and it reads the data. So now you are here. If you see, you are storing account number first and balance second. So when you are reading the data, you have to read account number first because you wrote account number as first. Okay. And you are reading the balance as second because you stored the balance as second entity. Okay. So let's see this example step by step. You start with random access file. And what is random access file? I told you that in order to access certain region of the file without going sequentially, we use random access file. Okay. So let's say first byte, 100 byte or 1000 byte. We are going to see this in this example. So let's say we define account 1. We give ID and the balance, and account 2, ID and the balance. At this point, we just defined a file and we define 2 accounts. Okay. So now we are going to say account 1 dot write data. Okay. So what is account 1? Account 1 is an object. It has an ID as an integer and it has a balance as an integer. And how do we know it's an integer? Because we defined it inside a construct, sorry, inside a class, not a the constructor. So when you say account 1 dot write data file, it's going to write 8 bytes. Okay. So you start from here, this account 1 dot write data. So it's going to take this data of account 1 and it is going to write it inside a file. But where is this function? Write data, it's here. So you take the name of the file, which is bank accounts dot dat. And now you are going to write an integer, which is account number. And you are going to write a balance, which is balance. The integer is going to take 4 bytes. Balance is going to take 4 bytes. So at this point, you have written 8 bytes to the binary file. If somebody does not understand how we have written 8 bytes in the binary file at line 37, please raise your hand, then I will explain later. So the whole idea is you created a class and you defined two variables, integer account number, integer balance. Okay. You just defined two accounts here, account one and account two. For account one, you wrote the data. And when we say account one dot write data, then it is going to use the instance variable of account one. And when we use account two dot write data, it's going to use the instance variable of account two. So at this point, we have written 8 bytes. Why 8 bytes? Because we have written 4 bytes for account number, 4 bytes for balance. So at this point, we have written 8 bytes. Okay, so now let's execute the second line. So once you have written 8 bytes here, and when you call account 2.write data, your data starts from the 9th byte, okay, in the file. And you again write 8 bytes. So now the total length of your file is 16 bytes, okay? 8 bytes for account 1, 8 bytes for account 2. And why 8 bytes? Because account number and balance, we store them as 4 bytes and 4 bytes. So let's see it like this. How to draw? Let's say you have this file. Okay, so let's say you have this file of 8 bytes. Okay, so here is your account number. And here is your balance. So that's for account one. Okay, that's for account one. And we have written 8 bytes in the file at this point. Okay, so when you run this command, it's going to create 8 bytes again. In the first 4 bytes, it's going to write account number for account 2. And in the next 4 bytes, it's going to write the balance of account 2. So basically, these are 8 bytes for account 2. So that is total of 16 bytes. Still, any question? We are here. Okay. So we are here and we have written 16 bytes to the file. Any question about how they are 16 bytes and how we have written like 4 variables of 4 bytes each? Okay. So now here is the main thing, this seek function. So when you call file.seek8, so let's first understand file.seek0. So let's say it's file.seek0. So let's say you have this. Let me remove this. So I assume that now I know that my file is of 16 bytes. Okay. The 8 bytes are for account 1 and 8 bytes are for account 2. So when I say file.seek0, I'm here. 0. When I say file.seek0, I'm here. When I will read the first 4 bytes, their account number. And when I read the next 4 bytes, that is balance. And when I call file.seek8, I'm here. And I'm going to read account number for account 2 and balance for account 2. So when I'm here, let's remove this. When I'm here at file.seek8, and if I read account, if I try to read the data from the file, I'm going to print account 2. Why? Because 8 bytes onward, I have stored the data for account 2. And between 0 and 8, the first 8 bytes, I have stored the data for account 1. So let's run this. Okay, so here I went to the 8 byte of the file and I read the account number and the balance and I printed it here, which is 1002 and 2500. Then I said file.seek 0. It means that I went to the 0th byte, which is here, and I start reading from here. The first 4 bytes for account number and second 4 byte for the balance. So I have read it, and in order to update the account, I got the account balance. I added 500. I went back to 0th position, and again I wrote the data where I wrote the account number and the balance. So if you see, I had 1500 before, and once I have updated, now my account one balance is 2000. Okay, so that's how you move from byte to byte within a file. And so now you know that 8 bytes are required for account 1, 8 bytes are required for account 2. So what I can do is I can keep saving account 3, 4, 5, 6, 7, 8, 9, 10, let's say, and I reach the 80th byte. So in order to change account 10, I will stop at f.seek 72. Okay. Why 72? Because 8 into 9 is equals to 72. Because we have passed 9 accounts, and for the 10th account, I use f.seek 72. Any question from here? It's very simple. What you are doing is you are just sequentially pasting the data inside the file, like first 4 bytes, 4 bytes. So now in exam, I can do something like this. So now we are storing integer here. Let's say I make it double, okay, and store it as double. And I told you that double takes 8 bytes, right? So now you need 8 bytes for your account number, 8 bytes for your balance. So your one account will be like 16 bytes. For the next account, you need to take another 16 bytes, and for the next, you need to take another 16 bytes. Or I can do something like this. I can take an integer for account number, but for balance, I take double. So now your account will be like 12 bytes, 4 bytes for account number and 8 bytes for balance. And once you have defined these things, once you have defined that how much space or how much bytes your account is going to take, then you just multiply 12, 24, 36, 48, 60. And now we will see what if we try to access something between, like, so here we have like 8 bytes. So we go from like this 0, 8, 16, 24, 32, 40, like the multiple of 8. But what if we try to access something like 5 or 6? What happens? So let's see this example. Now we have defined 3 accounts. Okay. Account 1, account 2, account 3. So what I do is I ran this write data function. So it has written 8 bytes because the class is similar. We have 2 integers, 4 for one integer, 4 bytes for another integer. So at this point, we have stored 8 bytes. Now what we can do is we can leave the 2 bytes in between. We go to the 10th byte, f.seek or file.seek 10. And what we can do is we can write account 2 here. So now your account 2 will be from 10 to 18, not from 8 to 16. Okay. This is something important. So your account 2. So as I have gone to, so let's see here. So I started from 0 and I stored till 8 bytes. So what I asked to my file is let's go to the 10th byte and store account 2, and it takes 8 more bytes, so it becomes 18 here, right? And these 2 bytes here, they are just wasted. It's nothing here. Okay. So that's one thing. And what you do is you try to access 11 and you write your data on 11th position. But if you remember that account 2 was written here between 10 to 18. So anywhere between 11, we have account 2 data. So if we try to do something like this, And if we run this function, now we have overwritten the account 2 data with account 3 data. So now we are seeking 11 and we are reading the data. And if we try to seek 10 and try to read the data, we get this weird number. If you see 3 dash, so the whole idea is if you don't go with the multiples, or if you don't know the exact location of the bytes, you cannot retrieve the data back. So when I was saying that if you are writing the data in some order, you have to read the data in the exact same order. So if I give you some file with some weird bytes and I ask you to read the data, and if you don't know how the data is written, you cannot read it. Okay. And that's how, I'm going to give you assignment 3. I will give you a file and I will explain your data. The data has been written in this format, like Alice, or Alice has, let's say, some balance or age or anything. So I will give you the whole information about the data, and then you are going to like import the binary file, get the data. So the whole idea here is if you don't know how the data is stored, there is no way you can get the data back, because you never know what is stored at 10th byte, what is stored at 15th byte, what is stored at 20th byte. Okay. So that's the whole point of random access file. We can jump from one byte to another, or we can go to different location of the file to store the data. But to get the data back, you need to know these locations. If you don't know how your data has been stored, you cannot get it back. Okay. So any question? No question? Okay. So I'm going to repeat again. Let's say you define a class and it has two variables, let's say int. Okay. So let's say first int take 4 bytes, next int take 4 bytes. So your one object will be stored as 8 bytes if you use random access file. There are some other ways to store objects and we are going to see later in the slides. But that's how things work. So compared to the text file where you just write the data, in the binary files, every variable or every data type has some allotted bytes, and you convert that data to hexadecimal to fit in those bytes. An integer will take 4 bytes. If your class has 2 integers, it's going to take 8 bytes, the object. If your class has 3 variables, 3 instance variables, all int, it's going to take 12 bytes. So now I expect you to understand these things. And if I give you some class, you see the number of variables, like, or the type of variable, they are int or string or double. And again, either you have the numbers like how much bytes it's going to take, or maybe in the exam I will give you integer take 8 bytes, double take, sorry, integer take 4 bytes, double take 8 bytes. So all this information I'm going to give it to you. What you need to do is use that information to write the code. Okay. So you don't have to memorize anything. You just need to use the things in a right manner. Okay. So yeah, that was about random access. And finally, we have object streams. So we started with text files, and then we reached to binary files, how we can represent our data in the binary format. And then we jump to random access file where we can access different locations of the file inside the code. And finally, object streams. So what we can do is we can define a file and we don't care about the number of bytes. Okay. So in the random access, we were saying, okay, we add this, go to this position, store the data, go to this position, store the data. But in the object stream, we just tell the Java compiler, I have an object, store it in the file. Now Java is going to take care of everything. We don't have to tell 4 bytes or 8 bytes or 12 bytes. Okay. So what you do is you define a, let's say, a bank account class. You simply use object output stream. You give the name of the file and you just say write object. Simple. And whenever you are going to read an object using object input stream, you need to use casting, because there is a possibility you are storing multiple objects in the same file. So now the Java compiler does not know what is the type of the object. So you need to define it explicitly when you are getting back. So let's see in the example. Yeah, so see, that's very simple. You have this bank account, let's say new account number and balance, and you just define object output stream. You define two accounts, and now you don't care about file.seek0, file.seek8. You simply use write object and you pass your object. Then you use write object and you pass your second object, and simply you close this output stream. And if you click on this, there is a file created, bank accounts.bin, and let's see. Yeah, so this bank accounts.bin, and again you see some weird characters because that's binary. Okay. So now compare it with random access file. You don't have to give file.seek. You don't have to care about anything. What you need to do is use this output stream object and write as many objects as you want inside a file. Okay. So the whole idea here is you use a class, you define a class, and if there are certain objects which are important to you, you can store them in the file. Okay, and maybe you can use them later by importing them. And how do you import them? Using object input stream. Again, order is really important. So in the previous file, I stored account 1 as first, account 2 as second. You cannot do something like this, read account 2 as first and account 1 as second. In the order you have followed to write the file, you have to follow the same order to read the file. So you again define object input stream with, and now you are passing bank account.bin because the file is available here. If you see here, and I am reading account 1, but I need to explicitly define the type of object, because when you have stored the object to the file, now the file doesn't know what type of object it is. So when you import it back in your Java code, you need to explicitly mention this thing. And in the next example, you will understand why we need to do this. Okay. So you need to do this thing. For account 1, you need to do the same thing for account 2. So now your account 1 has this information, and if you run it, this was the same data you used to store. So in the example 4, you use 1001 and 1500. In example 2, sorry, in account 2, you use account ID as 1002 and balance as 2500. So now you don't care about anything. You have an object. You use write object function to just throw all the objects inside a file, and you can do the same thing. You can follow the same order to retrieve those objects. And why we want to use casting? Let's see another example. Let's say there is this customer class, very simple. Like we have customer ID and customer name, and we have this constructor. Okay. And let's go to example 8. So what we are doing here is we are creating another object, objects.bin. Okay, so if you see objects.dat or .bin, they're all binary files. They are just different, just like the Word document is .docs and text is .txt, okay? But they do the exact same thing. They have different functionality. So if you see .dat file or .bin file, they are similar. They store the data in the binary format. So what you do is you create account 1 and you create customer 1. So this account 1 is of type bank account, customer is of type customer. That is something you need to think about. We have one file, but we are storing objects of different types. So before we used bank account, account 1 and account 2, but here we are storing different objects, account 1, customer 1. And you are writing these objects, and now to read them. So now when you have stored the objects inside a file, you don't know what is the position of account 1, what is the position of customer 1, or other type of objects you have stored inside a file. So what you do is whenever you read an object, you specify the type. Now the file or Java compiler doesn't know what type of object you are retrieving from the file. So you need to use casting to convert it to bank account object. And then you have to convert it to the customer to tell Java that it is a customer object. Treat it as a customer. Okay. So just to summarize, you can store objects inside a file directly using object output stream or object input stream. Okay. And what you can do then is you can retrieve the objects, but to retrieve them, you need to know the exact order. Account 1 was saved before, customer was saved after. So when you read account 1, okay, you need to follow the same order. Like you need to read account 1 first and customer second. So any question from here? That is very simple. Just I think the difficult thing is random access file. You just need to take care of the number of bytes you are actually handling. Otherwise, this thing is really easy. You just define a file and just throw as many objects as you want. But the main thing that needs to be noted is you need to follow the same order. If you are storing account 1 first, you need to read account 1 first. And while reading, you need to use casting. That is very important. Okay. Read and write array list. Yeah, I think it's not important. We will see data structures in the next class, so we will cover that later. But array list is nothing but just an array. And when you do something like this, so it means that there is an array that store bank account object. So you can put as many bank account in the array list as possible, but we will see that later. So yeah, that's it for now. And so now let's, if you want, just go to the lab and I will come and yeah.